Our Earth is a giant magnet, a fascinating and complex natural phenomenon. It has a magnetic field that surrounds us, like an invisible bubble, stretching far into space. This magnetic field acts as our shield, a protective barrier that is crucial for life. It protects us from harmful radiation from space, especially from the sun's intense solar winds and cosmic rays. Think of it like a giant umbrella shielding us from the sun's harmful effects. This umbrella deflects most of the harmful radiation from the sun, ensuring that only a small fraction reaches us. Without this magnetic shield, life on Earth as we know it wouldn't be possible. The planet would be a barren wasteland. Our atmosphere, our oceans, and even we ourselves would be exposed to the sun's constant bombardment of deadly radiation. This magnetic field is created by the Earth's core, a dynamic and ever-moving part of our planet. Deep inside our planet, molten iron is constantly moving, creating a dynamo effect. This movement generates electric currents, which in turn create the magnetic field that envelops our planet. It's a natural process, but it's essential for our survival. Without it, Earth would be a very different place, inhospitable to life. The Sun, our nearest star, is a powerful force. It is a massive glowing sphere of hot gases, primarily hydrogen and helium, undergoing nuclear fusion at its core. This fusion process releases an immense amount of energy which radiates outward and reaches us as sunlight. It's not just a ball of light and heat, it's a dynamic and often unpredictable celestial body. The Sun's surface is constantly changing, with sunspots appearing and disappearing, and solar flares erupting with little warning. One of its most dramatic activities is a solar flare. These flares are sudden, intense bursts of radiation caused by the release of magnetic energy stored in the Sun's atmosphere. Imagine a massive explosion on the surface of the Sun. This explosion can be so powerful that it releases more energy in a few minutes than all the energy produced by human civilization in an entire year. This explosion, called a solar flare, releases a tremendous amount of energy. The energy released can be equivalent to millions of hydrogen bombs detonating simultaneously. This energy travels through space at incredible speeds in the form of radiation and charged particles. These particles can reach Earth in just a few days, impacting our planet's magnetic field and causing geomagnetic storms. We call this a solar storm. These storms can disrupt satellite communications, navigation systems, and even power grids on Earth. These storms are a natural part of the Sun's life cycle. The Sun goes through an approximately 11-year cycle of solar activity, with periods of high activity known as solar maximum and periods of low activity known as solar minimum. They occur when the Sun's magnetic field lines, twisted and tangled by its rotation, snap and reconnect, releasing vast amounts of energy. This process, known as magnetic reconnection, is a key driver of solar flares and coronal mass ejections. These eruptions happen frequently, some small and some massive, and they send waves of energy throughout the solar system. Understanding these solar phenomena is crucial for predicting space weather and protecting our technological infrastructure. When a solar storm erupts from the Sun, it releases a massive amount of energy in the form of solar flares and coronal mass ejections. This energy, composed of fast-moving solar particles, travels through the vast expanse of space at incredible speeds, sometimes reaching Earth in just a few days. Sometimes this energy collides with our planet's magnetic field, which acts as a protective shield against these solar particles. This interaction creates a spectacular light show in our atmosphere, the auroras, also known as the northern and southern lights. Imagine a cosmic game of tug-of-war where the solar wind, carrying the Sun's energy, pushes against Earth's magnetic field. The solar wind, a stream of charged particles, impacts Earth's magnetic field, causing it to react and adapt. This interaction causes the magnetic field lines to compress and distort, creating a dynamic and ever-changing environment. The energy from the solar storm is then channeled towards the Earth's poles, where it interacts with the atmosphere. This interaction excites the atmospheric particles, creating the dazzling displays of light we call the northern and southern lights, painting the sky with vibrant colors. While auroras are a beautiful consequence of solar storms, these events can have other, less desirable effects. Our technological world is particularly vulnerable. Imagine a power grid going haywire, plunging cities into darkness. The same charged particles that create the auroras can also disrupt our satellites. These disruptions can interfere with communication systems, GPS navigation, and even television broadcasts. In extreme cases, solar storms can induce currents in power lines, overloading them and causing widespread blackouts. Section 5. Solar storms in history, tales from the past. We have long known about the power of solar storms. In 1859, a massive solar storm, known as the Carrington event, caused telegraph systems worldwide to fail. Some operators even received electric shocks from their equipment. More recently, in 1989, a solar storm caused a power blackout in Quebec, Canada, leaving millions of people without electricity for hours. These events serve as stark reminders of the sun's power and the vulnerability of our technological infrastructure. Section 6. Understanding solar storms, protecting our technological world. Scientists study solar storms to understand them better. By predicting these events, we can prepare for them and minimize their potential damage. Just like we monitor hurricanes and earthquakes, we keep a close eye on the sun's activity. Space weather forecasting is becoming increasingly important as we become more reliant on technology. Section 7. The ongoing dance between the sun and Earth. The relationship between the sun and Earth is a delicate dance. The sun provides us with light, warmth, and energy, but it also poses a constant threat with its powerful eruptions. Understanding this dance, this interplay of energy and forces, is crucial for our continued existence and technological advancement. As we venture further into space, our understanding of space weather will become even more critical. Section 8. Looking to the future, predicting and preparing for solar storms. As we rely more and more on technology, we must continue to study and understand solar storms. Scientists are developing new ways to predict these events and protect our planet from their potential harm. The future of space exploration and our technological civilization depends on it. We must learn to live in harmony with the sun, respecting its power while harnessing its energy for the betterment of humanity.